Hello, my name is Jaqueline Quintanilla and this is my birthday polynomial project. So first things first, I was born on December 9, 1999, so my digits will be 12091999. And if I were to flip those digits, I'll get 999-19021. And this is one of the polynomials I got, but I did not choose this one for the project. And as you can see here, there is no x squared, but that's because it was combined with the 0, making it disappear. And these are some of the options I graphed, but I ended up only with one option, which is the one I liked and I chose for the project. And it was 9x to the 7th power plus 9x to the 6th power minus 9x to the 5th power plus x to the 4th power plus 9x to the 3rd power plus 2x minus 1. And when I graphed it, this is my final result. So the major question was, how does this graph reflect me? This graph has many ups and downs, just like I have in life. Another way to look at it is by paying attention to the decrease happening in the graph. The first decreasing of the polynomial is long in depth. However, the graph turns and starts extending in a positive direction forever. Like the graph, I sometimes fall. The first time I make a mistake, I may fall really low, but I learn from my mistakes and slowly get back up. So here with the arrows, we can see that the decrease is really long, but the graph starts turning, and at the end it just keeps on extending positive forever. So we start analyzing the graph, and the first thing is looking for the domain and range. So domain is taking in consideration the x values and knowing how far the x's extend to the left and how far they extend to the right. And the range is pretty much similar, but only with the y values. So having that in mind, we zoom into the graph and we can see that the graph extends to the left and to the right infinity, which are the x values, and the y extends also from negative infinity to positive infinity, making both domain and range from negative infinity to positive infinity. For the y-intercept, that is when the line of the graph crosses the y-axis, which is this one, and the zeros is the same thing as the x-intercept, which is when the line crosses the x-intercept, which is this one. And as we zoom in, we can see that when it crosses the y, it is at 0, negative 1, making that the y-intercept. And it crosses the x-axis at 3 points, which are these. And as we zoom into these 2 points, we can see that the two x-intercepts on the left are negative 1.2893, 0, negative 1.179, 0, and on the right, it is 0.335, 0. And for the maximum and minimums, I only had one maximum and one minimum, which is where the graph takes a turn. For the maximum, I found it at negative 1.2388, 0.25728. And for the minimum, I found it at negative 0.7409, negative 3.446. And for the end behaviors, we can see by the graph that the graph keeps extending up or positive forever to the right, and the graph extends down or negative forever on the left. And since this is a positive odd polynomial, one end goes the opposite of the other. In this case, the positive one goes to the right and the negative one goes on the left. And here we can demonstrate with arrows. So this arrow is pointing to the left, which extends negative, and this other arrow is presenting the one on the right, which extends positive forever. So as a summary, this is my polynomial, and this graph really reflects me because even though I may fall really low sometimes, I learn from my mistakes and slowly but surely I get back up. As the domain and range of this polynomial, I found that they were both from negative infinity to positive infinity, or all real numbers. I only found one y-intercept and 3 x-intercepts or zeros, and this graph only had one maximum and one minimum. For the end behavior, since it was an odd polynomial, they both went in opposite directions, and the end on the right went positive forever, and the ends on the left went negative forever. So this concludes my birthday polynomial project, and thanks for watching.